There you go. So the videos yesterday that I posted didn't show up very well as I looked back at them, so let's try a couple of those examples. Hopefully they look a little clearer here. If you're given f of x, some function, and here's the function, I suggest jotting it down as I go through this. Given f of x is x to the fourth minus x to the third minus 13x squared plus 25x minus 12. And two zeros. And so when they say two zeros, they're really saying there's two solutions that they're going to tell you of this equation. One solution is 1, another one is 3. But it's a fourth degree equation, so that usually tells you that there's 4 zeros. Fourth power, 4 solutions. Third degree, 3 solutions. So you have 2 of them. Now you could have repeat solutions, but what we're going to do is we're going to use synthetic division. We're going to plug 1 in and bring x to the fourth down to an x to the third. Put 3 in, it'll bring x to the third down to x to the second, and then we can factor what's left over. If that doesn't make sense, just take a little peek here. This should be pretty exciting. So one of the zeros is 1, so let's use our synthetic division technique. Synthetic division, draw a line here. So you write the coefficients of each term here, bring the first coefficient down, multiply, 1 times 1 is 1, get 0, 1 times 0 is 0, negative 13, 1 times negative 13, negative 13, 25 plus negative 13, 12. 1 times 12 is 12. Luckily we have 0 like we'd expect. Now the next solution that they give you is 3, or the next 0. Let's draw a straight line here. Bring the 1 down. 1 times 3 is 3. Add, you get 3. 3 times 3 is 9. Negative 13 plus 9 is negative 4. 3 times negative 4, negative 12, 0. So what this boils down to, we had a fourth degree, now it's a third degree, now it's a second degree. This is x squared plus 3x minus 4 equals 0 after you take into account the two zeros they gave you. So now we can factor what's left. This factors very easily. If we got a negative here, it means there's one positive and one's negative. It's the only way to get negative 4. Now, positive 4 times negative 1 gives you negative 4, and if you just check it with the FOIL method, the x times x gives you x squared. X times negative 1 is negative 1x plus 4x. Negative 1x plus 4x, that'll give you the 3x. 4 times negative 1, negative 4. So our other zeros are x equals negative 4 and x equals 1. So let's draw just a quick graph here. Oh, that line is horrible looking, I'm sorry. This is what you do without graph paper. Oh, it's almost tragic. Let's go like this. 1, 2, wow, 3. 1, 2, 3. Let's go like this. 1, 2, 3, 4, 5. Nice. 6. Terrible. One of the zeros is at 1. Let's put a point at 1. One of the zeros is at 3. Another 0 is at 1. Again, that's called a double solution, so it has a multiplicity of 2. And another 0 is at negative 4. Wow, that is ugly looking. Let's call this negative 4. Sir, that's very ugly looking. Okay, sorry about that. So what do we know? We know we have x to the fourth power, and x to the fourth is an even function, and we know even functions rise both on the right and on the left, okay? The multiplicity of these are, except for 1, there's a multiplicity of 1 here. What that tells you is your graph goes through this point, and somewhere in here it turns around. We do not know exactly. You can draw it down to forever, but we know it's got to turn around and come back to this point somewhere. Now, since 1 has a multiplicity of 2, the answer is x equals 1 and x equals 1 twice. What that tells you is when the graph hits here, it touches and it goes down. Now, we can find the y-intercept by plugging, we're at the point here, x is 0. So go up to our original function. If we put a 0 in, we get 0 minus 0 minus 0 plus 0 minus 12. So the y-intercept is actually down here. Let's just pretend this is negative 12. Again, we don't know what really happens when it turns, but it's going to come back up to this 0. There you have your graph. We know for sure it rises on both sides because it's even. We know these are your zeros because we found them. And when there's a 0 and its multiplicity is 1, the graph goes through. When its multiplicity is 2, it touches and turns around. Goes through the y-intercept. Up here goes through because the multiplicity was 1. Let's do one other quick graph. I might be pressing my luck here, but f of x equals negative x to the 4th minus 6x to the 3rd minus 8x squared plus 6x plus 9. And it says zeros are 1 and negative 3. So we say negative 1, negative 6, negative 8, 6, and 9, and we do a little synthetic division. Let's put the 1 there first. You bring the negative 1 down. 1 times negative 1 is negative 1. Add negative 7. 1 times negative 7 is negative 7. Together, add that, negative 15. 1 times negative 15, this looks horrible. Negative 15 plus 6 gives you negative 9, and you see some light at the end of the tunnel. 1 times negative 9 gives you 0 here. What a glorious thing to see. And then let's go for our next 0 at negative 3. Put a negative 3 here. Draw another straight line. Negative 1, pretty straight. Negative 1 times negative 3 is positive 3. Negative 4. Negative 3 times 4, positive 12. Oh, good. Let's add negative 15 plus 12, negative 3. Negative 3 times negative 3, positive 9. Glorious. We have a remainder of 0. So what you have here is negative x squared minus 4x minus 3 equals 0. Nobody likes all those negatives, so let's just go ahead and multiply both the left and the right by negative 1. Can you do that? Sure you can. 0 times negative 1 is 0. All these become positive. And then you got something that factors quite nicely. X plus and x plus. How'd you know it's x plus, sir? Well, the whole thing is positive. The only way you get positive here and positive here is if both terms are positive. There's no leading coefficient here, so x times x. And 3 is prime, so it's got to be 1 times 3. This one's about as easy as it gets. So you got x equals negative 1 and x equals negative 3. While we're here, let's find the old y-intercept. That's when x is 0. So this is going to go to 0, 0, 0, 0, and 9. So we'll draw our picture over here. We'll smush it in. Hopefully this is showing up here. I have no idea. I'm brand new at this. Let's call it x and y. Oh, that's very nice. All right, so our zeros are at 1, negative 3, negative 1, and negative 3. So negative 3 is another double root. So let's just go 1, 2, 3, negative 1, negative 2, negative 3. There's 1 0 at 1 and 1 at negative 3. Another one at negative 3 and negative 1. Now we have an even function, even, which means rises right and left. However, there's a negative sign out front, so it falls on the left and it falls on the right. The y-intercept we said is at 9. Let's pretend this is 9 up here. Oh, that's kind of arbitrary, sir. Yes, it is. Now, we know it turns around. We don't know exactly. You're required to know how to find the zeros. There's 3 of them in the y-intercept. You need to know it falls on both ends because it's even with a negative out front. It has to come around to here. Now, at negative 1, that multiplicity was 1, so it's going to go through here. Now, we do not know how far down. Somewhere in here, it turns. And this is a double root, so it turns around and goes down. If you graph this with Desmos or a graphing calculator, it would look different, but these points would certainly be there, and so would the y-intercept, and the end behavior would be correct. Have a great day. I miss you guys. Thank you.